Dear friends, Aspirants is a collective of mathematics students, research scholars, postdoc fellows, and faculty members across India, started by myself in 2017. We used to organize several online programs, webinars, problem discussion sessions, test series to help the students who are preparing for different national level competitive examinations and PhD and PG entrances. All our initiatives are purely voluntary and free and also open to everyone, those who really have a passion to mathematics. Today, as a part of the problem solving session series, we have a special session, question paper analysis of the last CSIR NET examination. We blessed to have Mr. Lalit Thuwal, a research scholar from Indian Institute of Science, Bangalore, with us to handle this session. I would like to express my gratitude and thanks to Mr. Lalit for being with Math Aspirants. I'm sure that today's session will certainly helpful for anyone, those who are seriously preparing for any competitive examinations like this. I welcome everyone to this program. Welcome, Lalit.
Thanks, Professor, for the kind introduction and giving me opportunity to speak in front of CSIR NET aspirants. So students, today we will discuss this CSIR NET exam, which was recently held. Okay, so let's start. So this is your, we will start from part B, okay? So we have half an hour. So I will discuss part B and then some selected questions from part C. Okay, some very good problems. So I think I will not be able to cover these questions in detail. So I will go somewhat fast, but we'll let you know that how you will solve the problem. Okay, so this one problem. So you have given that you have two integers, P and Q be two non-negative integers. Consider the following statement. Okay, so there is an K integer K such that P plus K equal to Q, and there is an integer K greater than equal to 1 such that Q plus K equal to P. So you have this. Okay, so P plus Q, the difference would be this, and Q minus P equal to K and P minus Q equal to K. So now we have this, right? So we have asked that P and Q are given non-negative integers. So does there exist integer K satisfying this? So what do you think? Which one is correct? Can you solve it now? So you have to figure out the true statement. Anyone?
C, sir.
C. So for all negative integers P and Q, A and B is true. So yeah,
Sorry,
okay.
B.
B. Guljar says B. Okay, so now if you see that K and Q minus P and P minus Q negative to each other, right? So let me leave this to solve for you now. Okay, so let me move to the next one. Okay, so this one, let A equal to those rational numbers from 0, 1, whose denominator is a power of 2 to the power n some for some n, and GCD of PQ is 1. It means that it is in the reduced form, and this is the collection of those rational numbers from 0, 1 for which the Q is of this form. Okay, 2 to the power n and 5 to the power m, and n and m are non-negative integers. C is again the collection of rational numbers from 0, 1, and P by Q has a terminating decimal expression. Okay, so we have to figure out that which of the following is true. Okay, so definitely we can see that A is contained in B, right? That is very clear. Okay. Yeah. So And you must have seen this fact before in your 9th standard or 10th standard, that a rational number p by q has a terminating decimal expansion if and only if q, the factorization of q is like this, right? I mean, it is not divisible by any prime other than 2 or 5. So have you seen this? So B and C are equal sets, okay? It means the fourth one is correct. And this is part B. That's why 1, 2, 3 are incorrect. Okay. So we're now the next one. Let AB be non-empty subsets of N. And yeah. I can't hear you. Could you speak, please, somewhat loudly? So am I the only one who can't hear you? And so let me ask, can anyone let me know that, can you hear who is speaking? A judge. I can't hear you clearly, actually. So okay, if you can write it, okay? If you want to ask something, you can just write, okay, on the chat box. I will read and answer at the end. So let AB be two non-empty subsets of N with cardinality of A is greater than equal to. So cardinality of A is always greater than equal to 2. It's not a singleton. And let S1 is the collection of all functions from A to B, which are 1 to 1. Okay. And S2 is the collection of those all functions from B to A, which is on to. Which of the following is correct? Okay. So do you know that what is the number of all functions from a set A to B? Cardinality of the set, all functions. Anyway, this is, yeah, Guljar, tell me.
Sir, b to the a, b cardinality upon power a to the cardinality.
So this one, right? So let me tell you that which was the correct one. Okay, so see the third. If b equal to n, okay, then b equal to n means here you will have n, here you will have n. So the number of 1 functions from A to n, this will be n to the power cardinal, right? This will be this. And A is finite. Then this is, you know, A is finite means all functions, not, I mean, the all functions will be cardinality of n to the power cardinality of A. And this is a subset of set of all functions, right? That would again be countable. Okay. So cardinality of n, A times is again a countable set, right? You know that, I think. Right? So it's a countable set. So its cardinality is LF naught, not continuum. So the cardinality of this set in that case is also continuum. Then there exists a 1-to-1 map from B to S1, and B is equal to N. So cardinality of N is also LF naught. So both are countably infinite. So there is a 1-to-1 map, right? Bijective correspondence. There is a bijective correspondence. Okay. So this one is correct. Now you can discard 1, 2, 4 also. Okay, so let me leave those for you. The correct one is this. Okay, so the 24, let f r slash q to r slash q be the function defined as, this function is given and we have a sequence defined as the n plus 1 term is given by this. So if this sequence converts, where it will converge, do you know? It converts to the fixed point of fx, right? Because suppose that xn converts, then xn plus 1 also converts, xn, then we will get, I mean, say the limit is L, then L equal to 3L plus 2, and L will satisfy this, right? 4L plus 3. So now we will see that what is the possibility of L, but what question asks, suppose that there is a sequence xn converts to a real number L. Suppose that the sequence xn converts to the real number L, and we have picked a irrational number. We have decided what is x1, that is an irrational number. Which of the following statements are true? So let's check that where it can converge first, okay? So what is the solution to this equation? 4L square plus 3L plus 2, right? So we have 4L square equal to 2. From there, L comes out to be this, right? L is equal to plus minus 1 by root 2. It means that the limit of the sequence can be either 1 over root 2 of negative, okay, negative 1 over root 2, or positive 1 over root 2. So these three options cannot be true regardless of what L is, because the sequence can never converge to root 3 by 2, minus root 3 by 2, or minus 1 by 2. So the only option remaining is 2. Okay, so it must be correct. And because if L is positive, yeah, that's fine. I mean, if L is positive, then the positive limit can only be 1 over root 2, right? So this one. Okay, so let me ask you that how do you find this one? So there is a way, okay? Finding limit at extending to infinity is not a difficult task. Okay, you can do that, right? How you do that? So because there is only one correct option, right? We should be able to quickly know that which one is correct and we should move ahead. Okay, so sometimes in part B, it is easy to figure out the correct option, but in sometimes we find that the elimination is easy. Okay, so we solve the easiest one first. So we see that the third one says that the limit at infinity is 2, but finding limit is very easy, as I say. So this will be this. Now limit fx as extending to infinity comes out to be, you know, this limit is, I think you must already have seen this one. 1 plus 1 by x to the power x. This limit is e, right? Yes or no? Yeah.
Yes, sir.
Okay. So log e is 1. It means that this one is correct. And it says that f is unbounded and f is increasing and f is decreasing. So f is unbounded is wrong one, right? Because I have seen that at x equal to 0, it is 0. Limit exists at x equal to 0. And when we go to infinity, it also tends to a finite value. So it is a bounded function. So first one cannot be true. Now we only remain with that either 2 or 4 is true. Okay. So there are two ways. So either you can differentiate it and see that what's its a derivative. Is it always greater than 0, equal to 0, or less than equal to 0? Or there is another way that pick random 2 points. Okay. So what point is easy to pick? I think at 0, it gives 0 value, right? So at 1, the value is, although I know that the function is defined in 0 to infinity, still I'm finding the value at 0, because the limit at 0, if exists, it will be infimum in function if the function is increasing. Okay. Otherwise, it will be supremum. Okay, so we can check easily. Just pick 2 points. I'm just, avoiding the calculations because we have to, save our time in exam. So we have an easy way. Just pick 2 points which are easy. So I have put here x equal to 0 and x equal to 1. Okay, so putting x equal to 0 means finding the limit at x equal to 0. Okay, so at x equal to 1, what is the value of the function? It comes out to be log 2, and log 2 is greater than equal to 0. It means the function is increasing. right? Do you get that? So no need to make the calculations, okay? You have to differentiate, then you have to decide whether it is greater than equal to 0. That might, involve heavy calculations sometimes, okay? But sometimes it's easy to figure out without derivating, finding a differential coefficient, okay? So do you understand that? So in exam, you have to save your time, okay? Yeah. So now the 26, and you should also solve this question very quickly. So what you have given a sequence of functions fn to r defined as, sometimes students get confused, not all, but few students get confused when they see such kind of function. So it is a sequence of function, and you have given each fn, right? How f1 will look, how f2 will look. So, and you have to find that for each x it converts or not. First task is to find that, because we want to know that whether it converts pointwise or uniformly. Okay. So first of all, see, this is a part B question, and which of the following statement is true? It has been asked. Okay. So if the first one is true, say that fn converts uniformly on 0, 1 to a continuous function f, then the third one must be true, because uniform convergence imply the pointwise convergence, right? So third one must also be true, but that cannot happen in part B. So it means the convergence is not uniform. I'm just letting you know the common sense, okay? We will check whether it converts pointwise or not. So checking uniform convergence is not needed in this question. If you are sitting in the exam, save your time. Okay, no need to check the uniform convergence. I will also let you know the ways, but it's very easy. You don't need to check. You just need to check whether it converts pointwise or not. Okay, so let's see. So see, at x equal to 0, the fn 0 is a constant sequence, right? It's 0 for each n. See, because at x equal to 0, n into 0, so it comes out to be 0. It means the at 0 it converts. And for any x, see, for any x which is greater than 0, then there exists a m, right? Such that 2 by m is, right? Because 2 by m goes to 0, that's why there must exist a natural number m for any x greater than 0, which is in between here in the closed interval 0, 1. Right. So then if this happens, then this also happens to m plus 1, right? Because yes or no? So what do you get? Ultimately, your sequence, this sequence. So f m x, f m plus 1 x. So fixing x, okay? Suppose that you have fixed x. So this comes out to be 0, 0, 0, 0, 0. Okay. So ultimately, for each point, the fn x becomes 0. It means that converts to 0. So for each point, the sequence goes to 0. It means the third one is 2. Okay. You have to investigate the pointwise convergence. Without that, you can't solve the question. You don't need to investigate the uniform convergence. Okay. Because some of the student might, in exam, they will first see that, okay, it converts pointwise. Then they will check whether it converts whether this function is uniformly convergent or not, but that is not needed. I already told you, okay? And let me tell you another way to check that it's uniformly convergent or not. So yeah, I have another way to check it. So if it converts uniformly, then this sequence fn 1 by n, so it converts to where it converts to f and the limit of 1 by n, which is f0. But f0 is 0, right? But where this sequence converts fn 1 by n, you get this sequence is 1 every time, right? Because put here 1 by n in place of x. Then that converts to 1. So it means this convergence cannot be uniform. So this result you might have seen. Okay, so there are various ways you can solve. Okay, but always try to solve questions in exam very quickly. Okay, but accurately also. Okay, because solving quickly is not enough. So this 27 question, which of the following polynomials is the characteristic polynomial for the 2 cross 2 matrix A such that trace of A is 7 and trace of A square is 29? So it means that lambda 1 plus lambda 2 must be 7 and lambda 1 square plus lambda 2 square must be what? 29. Okay. Right? If lambda 1 and lambda 2 are the eigenvalues of matrix A, then this we should have because some of the eigenvalues is the trace of a matrix. So whose roots satisfy this? 1, 2, 3, 4. Okay. So if you see the fourth one, okay, it can be written something like this. T minus 5, T plus minus 2. But why do I observe only fourth one? Because I look at all the options first. Then I thought that, okay, 5 plus 2 can be 7, lambda 1 plus lambda 2, and 5 plus 2 are the roots of 4. So it means let's check. Then 5 square is 25 and 2 square is, yeah, that satisfies. Okay, so 5 square plus 4 square is 20, sorry, 2 square is 29 also. It means this is true. And we only have to find the true one, not the false one. Okay. Right. Now the question 28, what it says, let F5 denote the field with 5 elements. How many 2 cross 2 matrices with entries in F5 have rank 1? Okay. So see, if you have a matrix of 2 cross 2, it can have rank 2. Being rank 2 means it is an invertible matrix because it has a full rank, and or it may have rank 0. That means that is only 0 matrix, and all the remaining matrices has rank 1, right? Okay, so all of you know that what is the number of invertible matrices over some finite field, right? That is, I mean, very well-known fact. You must have seen that. So if you have a field with q elements, let me write it here. Field with q elements. So order of this group, I mean, this consists all the invertible matrices of n cross n over fq. So this is this, right? And this goes up to q to the power n minus 1. So now see, number of rank 1 matrices over F5 of order 2, okay? Order means the dimension 2 cross 2, okay? That means order of, so what are the number of total matrices? That is Mn, order of Mn F5 minus order of GLN, all invertible matrices means rank 2 matrices minus 0 matrix. Okay, they must, you might miss this one, minus 1, and they must have put an option like that. Yeah, see 145, because they also know that some student missed that. Okay, so whatever the possibilities of wrong answer, the I mean the one who is forming this exam, which constructing the problems, always keeps that option. Okay, if he or she notices that. Okay, so number of all 2 cross 2 matrices is 5 to the power 4, that is 6 to 5, and the order is 480. You can calculate that, okay, by putting in above formula, and this means this. So what is the, see how I solve this? 15, what is the unit digit? That is 4. So I will not solve it further because there is only one option with unit digit 4, and it means 1, 3, 4 are wrong because I have to save the time. I will not do the redundant calculations. Okay, even if it involves 1 second, if I don't need that, why shall I do, right? Okay, so see, let X be the R vector space of all twice differentiable real valued functions on 0, 1. Consider the linear map from that space to R cube, which sends a function f to its value at 1, its value at f dash 1, its value at f double dash 1. Which of the following statements is true? So you have to find the true statement, right? First of all, see, if this linear transformation is onto, then X char phi is isomorphic to R cube. It means its dimension is 3. So the first option asking whether the homomorphic vector space linear map is onto or not. Okay. So how someone solve that? So think that can we find a f such that we get image of f is 1, 0, 0, and can we find another f such that the image is 0, 1, 0? That's image is 0, 1, 0. And can we find the third one such that the image is 0, 0, 1? And at first glance, right, you will think that, yeah, we can do that, right? Okay, so let's try to do that. Okay, if this happens, then the first one would be true and all other options are not true. Okay, so there are two ways from here that either you see that this is onto or not, then 2, 3, 4 option. You can eliminate them also. The first one is true. Okay, so why? If you take the f equal to 1, right, the phi f comes out to be, this is constant function and its a derivative when it says 1, 0, 0. It means 1, 0, 0 is in the image. Now I want 0, 1, 0 in the image. If you take f equal to x minus 1, then the value of x minus 1 at 1 is 0. So in that case, this comes out to be this, right? Now, the last one, that what you choose in place of, you can choose a function whose root is 1, but 1 is a double root, because that will, then f1 and f dash 1 will be 0, right? And f dash, x minus 1 will work. So you might think that that will not give you 0, 0, 1, but we don't need that because we only need 3 linearly independent vectors in the image. Okay, so if you take x plus 1, then you get phi f equal to, because 1 is a root, so f1 is 0 in that case because it is a double root. So f dash 1 is 0. Here we will get some non-zero value. I don't care about that. It is 2 or 1. So in image, I get 3 linearly independent vectors. So 3 linearly independent vectors are in image. It means the vector space spanned by them will also be in image. So R cube will be in image. And image is already contained in R cube. So it means the image must be R cube. Okay. The first one is true. So this is a way to solve the correct option. But how do you eliminate? For 2, kernel phi is finite dimensional. Kernel phi cannot be finite dimensional actually, because if it is finite dimensional, so then, okay, so let me see, tell you some way. So can you tell me some quick way to decide whether or not kernel phi is finite dimensional? Because I have already told that here. So let me see how many of you observed that. Supritam. Okay, Supritam, let me know.
Yes, sir. Am I audible?
I can hear you.
Sir, what are you asking her?
I'm
Why
asking,
kernel?
can you quickly tell me that why
Yeah,
kernel phi is not finite dimensional?
because if we took finite dimensional, then can we apply rank nullity theorem here?
Yeah, you can apply rank nullity theorem and get the
But
image.
it is of the case of finite dimension.
Right. Okay, so let me tell you some other way. I mean, you can do that. The same proof of rank nullity theorem work here. So another way is to see that. So what I have told you, that this function will be, this will be in the kernel. How many of you can see that this will be in the kernel or not? X minus 1 to the power whole cube, because it has triple root. So, and all of its multiples, this ideal will be in the kernel. And this ideal is contains infinitely many linear independent vectors. This might not be vector subspace, okay, but this contains infinitely many linearly independent vectors, because the polynomial of different degrees are linearly independent over R, right? Because if you vary the degree of fx, then you will get the polynomial of different degrees. All they are linearly independent. So kernel contains this ideal. Okay, no, sorry, I mean the ideal of Rx. This is ideal of Rx, not X. Okay, so see, this is contained in kernel phi, and it contains infinitely many vectors. That's why it cannot be finite dimensional. Wrong it. And the dimension of X square phi is 1. It means that only, you know, the image is one dimension. Independent vectors at least. Okay. That means that it should look something like this, alpha times something, but that cannot happen. Okay. So X is finite dimensional. That is wrong. Why? Anyone? X is finite dimensional.
Because there is a in linearly independent set 1 x square x cube
Okay.
all that's a linearly independent set, and
Right.
any
Fine.
maximal linear set can
Because there are infinitely many linear vectors. Because second one is wrong. That's why the fourth one is also wrong. Kernel phi is a subspace of X, right? If kernel phi is infinite dimensional, then why X is finite dimensional? Okay. And the Aman told the right way also. Okay. Because if second and wrong, then fourth one is also wrong. Okay. Do you get that? Okay. So this one. Consider the matrix. It asks about the largest eigenvalue of A. So okay, I'm not going to do the calculations. So just let me know that is 101 is the sum of all row sum or column sum. Can you check that? Row sum, right? Okay, so it means 101 is an eigenvalue. That means it is wrong. So there is a bound about the eigenvalues called something, I don't remember the exact name. So you can check by that this cannot be an eigenvalue of 4. Okay. I mean 113 cannot be an eigenvalue, and 101 is an eigenvalue because of the rows. So it must be correct. So you will make the calculations. Okay. And now the third one is also, AJ. So I'm not going to solve that one. So let me tell you how to do that. Okay. You have given C0 pi, the real vector space of real valued continuous function. And we have a sequence fnx, and pick the V with the real subspace spanned by F1, F2, and F3. Consider the inner product on V is given by, this is the inner product defined, and which of the following statements is true. So we are asked to find that this is orthogonal set or not orthonormal set. Okay, so how will you start? So see, if 2 is true, I mean F1, F2, F3 is an orthonormal basis, then these will be orthogonal and these will be linearly independent, and they will span a 3-dimensional vector subspace. Okay, so how do we check that? First, you have to check this. Okay, F1, F2, these are the inner product comes out to be 0 or not. So it will involve some formula sin mx sin x, its integration is 0 or not. I think you already know that. Okay, so you have to check these 3 things. So this will tell you that these are orthogonal. Okay, so if they are orthogonal, then you have to find the norms. Okay, this for each I. Okay, fi. If they comes out to be 1, then this is a orthonormal basis. Okay, So this is your work. You can do that because it only involves calculations, nothing more than that. Okay. Once you find F1 and F2, then you will, catch a pattern and go ahead with the calculations. Okay. Is it okay? Right. So see. Now, I will use somewhat real analysis here, okay? So V is the vector subspace of all the real polynomials up to degree 3, and we define QF equal to this, f dash t whole square, okay? dt, let f dash denote the derivative of f, which of the following statements is false? So Q is a positive definite quadratic form. Okay. And Q takes every positive real value. Qx equal to 2. So Qx equal to 2, that's very easy to find because if you put x in place of f, then its derivative comes out to be 1. And if you integrate 1 over the interval -1 to 1, and you know that it's 2, right? That's easy to find. So it is true option, okay? And this is also true that Q takes every positive real value. So why? So first of all, this will always be positive, right? Non-negative, because this function is continuous and is non-negative, continuous non-negative function. So Riemann integral, and it takes non-negative values. So where it can be 0. So see now. Here you have to observe something, that constant functions are not there. Only 0 function is there, right? So it will be strictly greater than 0 if f is non-zero. Why? Let me tell you. Just use the concepts, theorems, and don't, do the calculations, okay? Suppose that your f is non-zero, then it must be a polynomial. Yes or no? Non-constant polynomial, right? Because we don't have here constant polynomial other than 0. So, and its derivative must be non-zero at some point. Okay. Its derivative may be constant, but its square is a function which is non-vanishing at least some point and non-negative, right? So derivative f dash t is always a non-negative non-zero function. Okay. Non-negative non-zero means it might take 0 values, but it is not identically 0. And you must have seen in Riemann integration theory that any function which is non-negative and continuous, if it is not vanishing at least one point, then its derivative is going to be strictly greater than 0. So it means that this QF is 0 only if your f is 0. Otherwise, it is never 0. So it means it is a positive definite quadratic form, and the range of a positive definite quadratic form, it is 0 to infinity. So the second one is also true. It means the only fourth one is not true. Okay. Otherwise, you can verify that fourth one is false. But I want that you should use something that is very quick. Okay. Which saves your time and which helps you to avoid the calculations. Okay, we don't even verify that it's linear or not. We just solve it from real analysis concept. So I hope you got, yeah. Any questions? So did you get the solution what I told you? Okay, just react if you told. Okay, fine. So many of you understood, right? Otherwise, just ask me, okay? I will write it I'm not writing because I don't have too much time, okay? Because I have 1.5 hour, and I try to explain whole of the part B, and I want to pick some good problems from part C, okay? So that's why I'm not writing everything here. So this says that, and this also involves some real analysis. See, let FC to C be a polynomial map for R greater than 0. You have given defined you circle of radius R. Okay, so this is the circle of radius R centered at 0, right? Gamma R. They keep on increasing as R increases. Okay, right? Yeah. So this integral is given. Suppose that there exists a C which is in R, and our this function f operation gamma R t gamma R dash t dt. Okay, tends to C. It converts to a real okay. So see, it says that C must be greater than, okay, which of the following false? Okay, so now you observe that this function is continuous. So let me tell you some result, okay, which I used above. So the result is this. Note it, because many of you might not know it, that if f belongs to CAB, it is a continuous function on the interval, closed interval AB, and it's a non-negative. Non-negative means it takes non-negative values for each x in AB. So, and there exists a point C. So someone is unmuted. Could you please mute yourself? Sneha. Okay, I have muted. So see, there exists a C in the closed interval AB such that FC is greater than 0, then this integral must be non-zero, strictly greater than 0. Okay, so this all follows from Riemann integration theory. So we will use it here also. See, this function f is a function from C. You have a function, continuous function from 0, 1 to C, right? Then you have a continuous function from C to C. It is f, it is your gamma R, and here from C to mod function, right? So see, this function is from this one, and mod of it is a continuous function, right? And this is also continuous. Their product is continuous. Overall, this is a continuous non-negative function. Okay. If this function becomes non-zero at some point, then its integral must be non-zero. Okay. Right? For every, R. For every R. And that keeps on increasing. Okay, so it means either C is infinity, or then C cannot be greater than 0. Okay, so this cannot be true. So this will always false. And when C can be 0, C can be 0. If you take 0 function, then you will get the 0 value. The function f is constant. This is true. And you can check that which constant function it is. Okay, so it must be 0 function. Okay, or otherwise for non-zero polynomials, the limit comes out to be infinity. You can work with that, okay, because we have already given FC to C is a polynomial map. Okay, so now the 34, what it says, let X be the image of the interval under the Möbius transformation FZ. We have given this Möbius transformation, and let me tell you, this is very important one. Okay, so question related to this is asked in many of the exams like GATE, NET, NBHM. I have many times seen this. Okay, so because this is a map which maps upper half plane to the unit disk. Okay. Bianalytic map. So what you have to find? You have to find the image of this interval, closed interval 0, 1. Okay. Image of this curve. So when you put 0, what do you get? So first of all, you should note that this is a map which maps upper half plane to unit disk and the boundary of upper half plane to the boundary of circle. Okay. So see. So its image will be a curve. So F0 comes out to be minus I plus I. This is -1. So F0 will be here. Okay. F0 will be here. Where is the F1? F1, 1 minus I, 1 plus I. So that comes out to be minus I. Okay. You will multiply with 1 minus I everywhere. So 2 will be in the denominator, and in the numerator you will get minus 2i because 1 minus I square. So this comes out to be the final answer, minus I. So here is the minus I. It means either this is in the image, either this one or this one. So -1 to I. X is the line segment joining -1 to I. No, because the line segment -1 to this one. Okay. So this is incorrect. And this says that theta equal to pi. Theta equal to pi means e to the power I pi. And this might be correct. Okay. So what are other options? X is the line segment joining -1 and 1. This is wrong. And this says that X is when theta is -pi/2. So this is like this, right? No, this says that this. Okay, so for this you have to check, just put a point, in between 1/2 and check that which point comes from here or here. Then you will get to know that if you get a point from here, then it means this curve is the image. Otherwise, that will be the image. Okay. So the correct one is, let me tell you, the correct one is this one. This one. Okay. Which of the following statements are true? It's true. Okay, so how many of you appeared for this exam? So could you please raise the hand? So I get to know that how many of you have seen this. You felt and you solved the questions or not. So okay, so here so what I have told you that this function is very important, and the questions regarding to this function has been asked in GATE 2024 once and GATE 2025 in also. So you can check the complete playlist for the solution. There you will get the solutions, okay? Detailed solution for those questions. And those are very nice problems. Those are usually asked. So let me tell you where you can watch. You can just go to the 𝐴𝐸 Mathematics YouTube channel and go to the playlist section. Once you go to the playlist section, then search it, see that where the GATE playlist are. Okay. In the GATE 2024 and GATE, there is a question in GATE 2025 also that will also be recently uploaded in this channel. So you can check that question. Okay. I don't remember the exact no. Okay, so I remember what is the number of that question. The question number 36, I think that one, or 37 in the GATE 2024 playlist. Okay, check that question. That is very nice question, and you will feel, very interesting, that one. Okay, so this that also involves this function and Schwarz lemma. That is very nice problem. So it came to my mind. So I thought that let me tell you. So which one of the following statements is true? This is very nice problem. So I just want to know that how many of you could solve this in the exam. So could you raise the hand if you could solve this in the exam? Okay, very good. So for this, you nothing have to do. Okay, you just have to see. Okay, so in this way, do you solve or not? So if this is an entire function, then fz, it has a power series expansion. Fn 0 over n factorial z to the power n. And this is an. The radius of convergence of this an should be infinite, right? Just divide fn0 by n factorial, then whatever term you get, the radius of convergence of that power series. I mean to say that first, this is your an, right? N factorial divided by n factorial, and this is an. Now, use this formula. I suppose that you have this power series. Okay, so this power series converts for each z. It means the radius of convergence should be infinite. So for which of the following here radius of convergence is not finite? So that will be your. So I think this one, right? In case n minus 1 factorial, if you divide n minus factorial by n factorial, then what do you get? So you get 1 by n. And we know that the radius of convergence of this series is 1, right? So it means this cannot be correct. This is the question of power series. So did you solve the question in the same way, or do you have some another way? Okay, so you have solved in the same way, right? Okay. So now for another 5 minutes, we will discuss part B. Then I will solve
Sir,
some.
I think
Yeah,
this is
but
not the answer.
not the correct answer.
Yes, sir.
Okay, so you can check. I mean, so fn by n factorial 1 by n. So what is the radius of convergence of 1 by n? So which one is the correct then?
Sir, 1.
1 is the correct. I mean, they. Oh, I actually I have found there does not exist. So what I said that its radius of convergence is 1. So such kind of function cannot be entire. Yeah. Okay. So all 2, 3, and 4 will satisfy this. Okay. Their radius of convergence, when you will divide them by n factorial, comes out to be less than infinity. Okay. So you all can check that. Okay, students. Yeah. Sorry for the wrong mark. Okay. So do you get the idea behind it? Because fn0 over n factorial are the an. When you expand your function, entire function in the power series around 0, then you get fz equal to summation a and z to the power n. And this is a power series. It means the radius of convergence must be infinite. And for only option 1, this is infinite, right? 1 over n to the power n, right? Because if you take, 1 by n, then this comes out to be 1 by n, and it goes to 0. The radius of convergence is infinity. Okay. Clear? Everything is clear? Okay. So for another 5 minutes, we will discuss part B, then we will move to part C. Okay. So let f be an entire function such that fc is contained in this. Okay. So the image of f is contained in this line. Right. It means the image is not dense, and every entire function which is non-constant has a dense image. It means this function must be constant. And if this is constant, then here you have every time constant, right? A c by z, its limit is 0, obviously, when z tends to 0. Okay, so this option is true and all other options are wrong. Okay. So which of the following statements is true? This is Fermat's theorem, right? So you know that p minus 1 factorial congruent to minus 1 mod p, right? So this says that Fermat's theorem is not true, first one. So this is wrong. And the second theorem is, it is called Fermat's theorem, right? Or Wilson's theorem.
First one.
Wilson
Huh?
theorem, first one. Second one
First
is
one is Wilson.
first
The
one is
second one
Wilson
is
theorem.
second one is
Fermat's.
Fermat's theorem. Okay. So statements what correct are correct, so they will not affect the answer. By the way, we should know the correct names also. Yeah. Okay. So this is Fermat's theorem. You know that whenever GCD of A and N see GCD of 1, 2, 3, 4 and all odd primes, all primes which are greater than 700 will not divide 1, 2, 3, 4. You just have to factor 1, 2, 3, 4. Okay. So can you do that? Because 2 will divide that. If you divide it by 2, then you get 6, right? And no prime now, because 2 divides that, and 617. 617 is not divisible by any prime which is greater than 700, right? It means that no prime greater than 700 divides 1, 2, 3, 4, right? It means the GCD of 1, 2, 3, 4 and P is 1, right? Yes or no? If the GCD of 1, then by Fermat's theorem, what should we have? 1, 2, 3, 4 to the power 5p minus 1. 5p, it means it is p minus 1 is congruent to 1 mod p. Okay, it means the second one is true and these must be false. Okay. Right. And the 38. Let's solve this one also. Let A be a subring of the field of rationals Q such that for any non-zero real number R belongs to Q, either R is there or 1 by R is there. Okay, so which of the following statements is false? So let me tell you that this is localization, and this is a discrete valuation ring. So discrete valuation ring always a local ring and a PID. Okay, so if you have not seen what is a discrete valuation ring, then you can check about it. Okay, discrete valuation ring. So if you have seen the algebraic number theory, or you have done in your MSc algebraic number theory course, then you must have seen this discrete valuation ring or commutative algebra course or somewhere else in the algebra. So and if you haven't seen, you can check it out. Okay, that's not very difficult ring. So only to know, I mean, what are its definition and what are the properties. So a discrete valuation ring is always a PID. I have also, to local PID is a local PID. So there is a question in the last exam also, which is from a local PID. So I have solved that one also. So this is asked in CSIR net. I'm forgetting actually. It was asked last time or the last of last time. CSIR net December. So can anyone of you let me know the local PID question in part C was asked last time and or the last of last time?
June.
June. So do you remember correctly that it is asked in June, not the last time?
Yes.
Okay, so June
Yes,
part
sir.
C. Okay, so please watch that question, the solution of that question. So that also involves this kind of ring. Okay, I mean a local PID. So that is also a discrete valuation ring, or here maybe December. Okay, so how can you watch? Just go to the playlist section or in the home of Ing Mathematics YouTube channel, and where I have solved every question of CSIR net exams in very detail. Okay, so you will learn a lot of concept from that one. Okay, I mean you will learn a lot of new things. Okay, which help you to deal such kind of questions in the exam. So watch that. Okay, so in mathematics, and go to the playlist and find that was a part C question. Okay, you will find that in the playlist. Go to the playlist and CSIR net June 2023 or CSIR net 2024 or CSIR net December 2024. So in one of them, in the part C, there is a question of local PID, and that was very nice. Okay, so I remember you can check it out there. So it is a local PID actually. Local PID means it only has a maximal ideal, and every maximal ideal in a PID is a prime ideal. I mean, only maximal and every non-zero prime ideal is also maximal. So it has exactly two maximal ideals. One is 0 and another maximal ideal is which is maximal ideal. Okay. The collection of all non-units. Okay, so otherwise, if you don't know this local PID, discrete valuation ring, so how do you solve that? The first one is easy to verify that that's true. And how do you solve the second one, that A has at most one maximal ideal? Because see that those elements for which 1 by R is not in A forms the set of all non-units. So if 1 by R is not in A, it means that their inverse and all other elements which is outside, that set is a unit. The collection of all non-units forms a ideal in this ring. You can check out that. Okay. So it means that this must have a unique maximal ideal. Okay. This kind of exercise you must have solved. Yeah, Ankit, what do you want to ask? Okay. Okay. So you can check it out. Okay. Easy check. So, and another way to see this, that every subring between Q and Z is a localization of some of the multiplicatively closed set of Z. So all localizations are local. Okay, they are local PIDs, local rings. They are local rings. So you can solve like that also. And what I said, that if you don't know all these things, this question also can be solved very easily. What I told you, that for this, that it has a unique maximal ideal, you just have to check that all non-units forms a ideal that must be maximal, easy to verify. And this is a very easy check. And this is also very easy check. It means all these are true. That's why this is the only option which is false. But if you know the algebra, advanced something, then you can quickly solve such kind of questions. Okay. In your MSc, I mean, you can learn all those things. Okay. That is not something advanced which you learn in your PhD. So in MSc, you see these courses, combinative algebra. If you are interested in algebra, so you see these kind of things. And you will find all this in Damit and Foote, not in very advanced book. Okay, something. You will find these all things, discrete valuation rings and all. So the last, okay, let me quickly give you the idea for these all questions. And I want to move to the part C because I have, 24 minutes remaining. So I will solve them quickly, okay? Because I want to discuss some really nice problems from part C. And don't worry, I will pick somewhat easy and some difficult ones so that everyone here gets something, okay? Because I know that many of you are very new and who might just be preparing for CSIR net exam and not very, they might not have very good grip on the concept. So don't worry. I will discuss some questions which can be solved just by knowing definitions, and those are easy. Okay. So stay. So this one, that which of the following statements is true? So it asks that which of the following ideals is maximal. The first option, this cannot be maximal. Why cannot be maximal? Let me tell you, because 2Zi. 2Zi means ideal generated by 2 because it contains that. If you multiply 1 minus I, 1 plus I, okay, this is in 2, ideal generated by 2, but none of them is in ideal generated by 2. Okay, so this is not even a prime ideal. So let alone be being a maximal. Okay, so and the ideal generated by X is contained in ideal generated by X and Y, so it cannot be maximal. Okay, and otherwise, if you cosine this by the ideal generated by X, you are killing X, so you get CY. This is not a field, but a integral domain. So this is a prime ideal, but not maximal. Okay. So the set of all polynomials in CX whose coefficient adds up to 0 is a maximal ideal. It means those polynomials from CX for which F1 is 0. Okay. So this is the kernel of this map from CX to C. evaluation map. Evaluation map means which sends any polynomial fx to f1. Okay, so this map has this kernel. So let's call this map phi, and this is the kernel by first theorem of isomorphism, because this is easy to check that this map is also, this is isomorphic to C. Okay, and it means the quotienting it by kernel phi, this ideal comes out to be a field. It means it must be maximal. Okay, so it is true. And the fourth one is wrong also. So let me leave it for you. Can you find the ideal which contains it? Okay, so and something here you can, and proper ideal. Okay, let me leave it for you. So now let me move to the part B, part C, and solve some of the questions from part C. And I will definitely try to give you another session in here Maths Aspirant if I will get time, when I will be discussing all the part C questions in detail. So let me quickly tell you how do you solve this. Okay, so you have to find automorphism, all the homeomorphism from S to S. So you just have to notice that one must map to one. Okay, if one must map to one, there are number of maps which from S to S11 and on to is 24, and all those must be homeomorphic. So, and how do you solve this kind of question? See, to solve this, X is given to be a solution, and it says that the general solution of ODE is given by. So you have to know that which is the another solution of this ODE. You don't have to solve this ODE. Just see that. Just pick e to the power ax and check that e to the power ax is it's a solution or not. If not, then these three will be wrong, and x e to the power xn must be a solution. And these two are linearly independent. Okay, you can check with, you don't need to check here, but if you want to check because you are at home, not in the exam hall, then you can just take wrong scan and check that they are linearly independent solution. And if you have a differential equation of degree 2 with then it has two linearly independent solutions at most, and all other solutions can be written as their linear combinations. Okay, so this is a well-known theorem. So in this way you solve this, and for this solve this, then you become a Cauchy-Euler equation of something like this, and then solve it. You will get lambda equal to I don't know what do you get when you solve this, but what is the correct answer?
B.
B. Okay, then you get the B. Okay, so it's easy to solve. Okay, just solve this one, differentiate it, and then you will get the Cauchy-Euler equation, homogeneous equation, you know, and put x equal to a to the power z, then go ahead. Okay, you will get that. And this one can be solved in exam very quickly because examiner misses something and didn't notice it. So what has been given that ux is equal to 1 plus x, and you are asked to find what is u11. So from here you can just find, right, everything. I mean, u11, put x equal to 1, then you get 2. Okay, so this is the correct option. No need to solve this in the exam. Okay, so many of you might have observed this in the exam. So how many of you could observe this in the exam? Let's see. So, and if you, I mean, raise your hand only if you observe. Okay, you don't need to be smart. Okay, so right. Okay, so many of you could observe it. Very good. So such kind of questions are there in part B, and you have to be, I mean, a good observer also. Okay. So what should I call? I mean, you should have a practice. Okay. First you have to see the initial conditions. You have to check that whether do I need to make the calculations, or without calculation I can do this. Okay. So that will save your time. Okay. You have to avoid the heavy calculation in the exam, because if you have more time, then you will be able to attempt the more questions, and your score will be good, and you have to be accurate. Okay. Accuracy also matters. Not solving very questions matters in the exam, because you have, suppose that you have attempted of 200 marks and overall score is 80, then that's not a good thing. So you would have attempted only for marks 120, and it is accurate, then you are a JRF, right? So yeah. Okay, so how do you solve this? UXTB a solution. This is the DLMBET. You can use the DLMBET wave equation solution, and the answer is 5. Okay, and this is of cubic spline, and the properties of cubic spline that it is continuous, and you can use the left hand limit, and it is continuously differentiable. If I remember correctly, you can check the properties of cubic spline, and using those you get the equations and ABC, and then find 2a plus b plus 2c. Okay. For this one, this is very easy, that Cauchy-Euler equation, Cauchy-Lagrange, what is that called? Euler-Lagrange equation you can use, del f by del y, and you can find the extremal. Okay, so then, I mean, not difficult to solve. Okay, so how do you solve this? This can be solved something like this: yx equal to x square plus x is here, yt, because yt is a continuous function, and this will be a constant, okay, because this is a definite integral, and this is this. Now yt comes out to be t squared 2tc. Put it here, yt equal to t square plus sorry, yx. Put back it in the equation, 2t. 2 here, you will get what you okay. So where we are going to put it now? Yx equal to x square. Okay, x, right. So yt equal to 0 to 1. I mean, t is there, right? Okay. So put the value of yt and then integrate and get the solution. Okay. Right? Yeah. So you can do that. Okay, let's move to part C. So I have only, 15 minutes. So I want to pick some very good problems. Okay. What you might not have solved in the exam. So let me pick it from complex or, okay. So let me tell you some, this one. Okay. How to solve this one. So I had thought that I would solve at least 4 or 5 questions, but for that I didn't get the time. So let's solve some good problems which you might know which you might not know the answer. Okay, so I'll come to you after this solution of this question. Okay, so let f and g be real value.
Hello, sir.
Yeah.
Sir, previous question one time repeat.
Previous question one time repeat. What does that mean?
This is x जो इसके पहले वाला सा क्वेश्चन था जो आप बोले कि इसके आगे कर लेना.
अच्छा. इंटीग्रल इक्वेशन वाला.
या
उसमें क्या रिपीट करना है?
ये सर ये मतलब इसमें जो कि मतलब सर इसका जो लिमिट है इसमें सर कैसे सॉल्व करेंगे? अगर इसको सर लेबनीज लगाएंगे तो वो मतलब 0 नहीं हो जाएगा?
ये लेबनीज लगाने की आपको आवश्यकता नहीं है ना. आप ऐसे करिए, सी इसको फिर यहाँ से सॉल्व करिए, इंटीग्रेट करिए यहाँ से, फिर उसके बाद सी की वैल्यू निकाल दीजिए, सी की वैल्यू यहाँ पर रख दीजिए, आपके पास आएगा. सो ओवरऑल सॉल्यूशन क्या आ रहा था, मैंने सॉल्व किया था. लेट मी टेल यू व्हाट इज द ओवरऑल सॉल्यूशन. ओके, wait.
Okay, sir.
I mean, you can do that, right? That calculation. So overall solution आ रहा है तुम्हारा yx equal to x square plus x square plus 3/2x. Okay.
ओके सर, बट जैसे जो न्यूटन लेबनीज फर्स्ट वाला होता है जिसमें 2 वेरिएबल रहे, उसको सर डायरेक्ट अप्लाई नहीं कर सकते?
कर सकते हैं, बट अगर वहां से हो रहा है तो आप किसी भी क्वेश्चन को कई तरीकों से कर सकते हैं. मुझे लगता है ये आसान है, यहाँ पे सी पुट करके लेबनीज रूल से आसान पड़ रहा है तो उससे भी कर सकते हैं. ठीक है, मैंने वैसे करके देखा नहीं है तो देखना पड़ेगा लेबनीज रूल अप्लाई करके हो रहा है या नहीं हो रहा है. ओके, चल. So यहाँ देखो बच्चों, so let me tell you this one, that f and g be two real valued Riemann integrable functions on closed interval AB such that g of closed interval AB is contained in closed interval AB, right? I mean, it means that f operation g is well defined. Okay. So which of the following necessarily are true? So let me tell you a result. a function f is Riemann integrable, a bounded function on closed interval, okay, is a Riemann integrable if and only if that set of discontinuities of f has a zero measure. Okay, so keep that in mind. So if you know that, you will be able to solve. So here f and g both Riemann integrable functions. So you can, suitably choose f and g such that the set of discontinuity of f operation g is not a set of measure 0. Okay, so choose that. Make it something like that, Dirichlet function. Okay, f operation g. That can be done. So in that case, it need not be Riemann integrable. So it says that if gx is not 0, then take fx equal to 1 and g equal to x or something like that. Make it unbounded, I meant to say. Okay. Unbounded function. 1 by x and define something at, you can take the closed interval 0 and define x at 0 something else. Okay, say at 0 we define 1. That will not, spoil the Riemann integrability, because a function which is discontinuous at finitely many points is Riemann integrable. So 1 by x becomes unbounded. Okay, so that is not Riemann integrable then. The positive square root. See, you have f square plus g is Riemann integrable, right? So it means it has discontinuities in a set which has measure 0. But if you take the square root, the discontinuities of this function can be at most, the set of discontinuities of this function can be a set of 0 measure, right? Because wherever f square and g square are continuous, then if you apply the square root, if you compose square root, then you get the continuous at that point. So only discontinuity can be on those points where f square plus g square is discontinuous, right? Because that is Riemann integrable, but that must be discontinuous. That is continuous almost everywhere. Okay. In major theoretic language, we say like that. That is continuous almost everywhere. So this function is continuous almost everywhere. So that's why Riemann integrable. Okay. The same thing is that if f and g are continuous, then their composition is continuous, and the continuous function on a closed and bounded interval is Riemann integrable. So this is correct. Okay. So let me pick one complex analysis question, what I was thinking that I would solve. So that is very nice problem. Okay. This one. Because it involves Schwarz lemma, it involves open mapping theorem, it involves something else. Let's see. So how many of you could solve this in the exam? So most of you couldn't. Okay, that's why I'm solving it here. Okay. So you might not have solved it yet. So let me tell you something before I proceed to this question. So I have discussed about the automorphism of unit disk. So I'm not going to prove that here. Automorphism of unit disk in a lecture. Where will you find that? Let me tell you. Automorphism of unit disk looks like this. E to the power I theta z minus alpha 1 minus alpha bar z. Okay, where this alpha is a point of disk. Okay, and theta is a real number. A theta is a real number. Is it correct or not? So many of you have seen this before, right? The automorphism of unit disk arise in this way. Okay. So see, if some automorphism. Okay, how well you will see this proof? So let me tell you, this involves Schwarz lemma. Okay, so a very good application of Schwarz lemma. So there is a lecture 17 II and 18 II in Ing Mathematics YouTube channel. Okay, So go to the playlist of in mathematics YouTube channel and go to the lectures, demo lectures for complex and real analysis. There is a playlist of that. So there you will get these two lectures. And in these two lectures, I have discussed about, I have, what I have discussed, Schwarz lemma, Schwarz-Pick lemma, and very good problems are there. Okay. So I have seen that many of the problems have been asked in the exams like NBHM and other exams, GATE, and this also involves this, okay, this problem. So let me solve it. So you can watch that and clear all these things, okay? You will get to know that how this happens, and you will also learn a very good problems from this. So check it out, okay? That those videos are public and you can freely enjoy that. So now let's solve this, okay? So this one, you have punctured disk, right? You have punctured disk. It does not involve 0. So 0 is not here. So you have a map from D to D. You have a map. See. Let me solve it in detail, okay? Be the punctured unit disk and F is a bijective holomorphic map from D cross onto itself. We have a bijective map. Bianalytic map means, so which of the following statements is true? So first of all, we are required to find that limit z tends to 0 f z exists or not in these 3 points options, right? So see, in the any neighborhood of 0, the image of it would be bounded, right? Because it contains inside the punctured disk, which is bounded, right? The image of any neighborhood of 0 would be bounded. So by Riemann's removable singularity theorem, says, by Riemann's removable singularity theorem, we can remove the singularity. So if we can remove the singularity, it means this limit must exist, okay? Exist, right? Exists. First of all, it exists. So we will see what it can be. It means now your function can be extended from open unit disk to open unit disk. You can extend your function to open unit disk, okay? So what can be the possible value of this limit? Okay, so see, this, if you find this limit and define your function, I mean f0 will be defined like something this, and by Riemann's removability theorem, f will be extended to analytically to D, right? That means that the image of 0, if it is outside, then the image of connected set is not connected under the continuous value. It means it cannot be, it is not possible. So it cannot be even in boundary because of the open mapping theorem, because it is then the image of open set not going to be open, right? Because it will involve a boundary point, which is not an interior point of the image, right? So it means the limit value of f0 must be inside the disk, okay? It means the second one is true. Second one is true. Now, can it be should it be 0? Yeah, it should be 0. Suppose that it is a non-zero number, okay? Suppose that here, okay? So say it is z2. Then what's the problem? So some of you might think that, oh, we have lost the injectivity. No, because we have given the function is injective from punctured disk to punctured disk, okay? So this might happen. So see, if this happens, because it is a bijective map, right? So there will be some point which comes to this. Yes or no? Right? So you should react, okay? I will think that you are following. Okay, so now take two disjoint neighborhoods, okay? Say you can pick two disjoint neighborhoods, right? I mean, or these 2 points because it's a Hausdorff space. So we have picked now its image, take their image, say V and W, then it's W and it's V, then FW and FV. This is a open set, right? Yes or no? Why? Aman, why this will be an open set? Non-empty open set. See, because W is open, so by open mapping theorem, sorry, not W, FV is open, V is open. By open mapping theorem, FV is open, okay? And FW is open also by open mapping theorem. So the open sets, 2 open sets have a 1 point in common, right? So that point is an interior point. So there is a disk which contained in both. So it means it is a non-empty open set, and non-empty open set is uncountable, right? So what does this means? That there is a point. So injectivity lost. I mean, many of the point coming to the same point, right? Because your function is given to be injective. So it means 0 cannot be outside, 0 cannot be other than 0. Okay, so the limit of 0 must be 0. Okay. How injectivity loss? Let me tell you. 0 can be go to some point, right? Because this is non-empty. There are some points which from here which comes here, and there are some point which comes from here. The injectivity lost in that case, right? Because this is a non-empty set. Do this, okay? You can do that at home and understand well. So FZ must be 0. Okay, so it means this is true. And the last one, see, what we get, then 0 goes to 0, right? So by extending, we get an automorphism of, what? Unit disk. Suppose, let me denote the map again by D because we have extended it. Now we have an automorphism of unit disk which sends 0 to 0. Now see, what are the automorphisms which sends 0 to 0? It means that it must be 0, right? Alpha must be 0. Otherwise, 0 will not go to 0. You can check that. Okay, so it means your function looks like this, Z(e to the power theta). Okay, so this is very nice problem. So FZ is equal to Z(e to the power theta). Okay, so I hope you get the solution. Okay, if you have any question in this, then please feel free to ask, and I would like to stop after that. Okay, so do you have some questions?
Sir, first two option.
First two option.
0 वो समझ में नहीं आया।
कौन सा वाला?
एग्जिस्टेंस, लेकिन लिमिट 0 होगा वो वाला समझ में नहीं आया। अगर आप
अच्छा, पहले ये समझ में आ गया कि बाउंड्री पर नहीं हो सकता और बाहर नहीं हो सकता। बाउंड्री पर नहीं हो सकता और बाहर नहीं हो सकता, राइट? हेलो अमित, तो अभी आप सोचो कि एफ डब्ल्यू और एफ बी का इंटरसेक्शन नॉन एम्प्टी ओपन सेट होगा ना। जैसे मान लो कि इसकी इमेज ये आई, मान लो कि इसकी इमेज यहाँ पे आई, ये इस पॉइंट को कंटेन करनी चाहिए, और इसकी इमेज भी कुछ ऐसी आई, वो डिस्क की तरह नहीं आएगी बट ओपन सेट आएगी। तो इनका इंटरसेक्शन देखो, इनका इंटरसेक्शन कुछ ऐसा आया, समझ लो, ठीक है, रफली। तो इनका इंटरसेक्शन का मतलब क्या है? मतलब यहाँ के जितने पॉइंट हैं वो यहाँ के भी एलिमेंट्स की इमेज है, इस नेबरहुड के एलिमेंट्स भी इसमें आ रहे हैं कुछ, और इसके भी आ रहे हैं, राइट? अब एक 0 तो सभी अनकाउंटेबली मैनी पॉइंट्स पे नहीं जा सकता ना, 0 के अलावा पॉइंट भी तो जाएंगे यहाँ से।
हाँ सर।
हाँ, तो फिर यहां से तो पॉइंट जा ही रहे हैं उसमें, तो इसका मतलब इंजेक्टिविटी देखो, अब जीरो को भूल जाओ, आप एक पॉइंट यहां से उठाओ, एक पॉइंट यहां से उठाओ, उनकी सेम इमेज आ रही है ना कहीं, तो इंजेक्टिविटी लॉस हो गई कि नहीं होगी? ठीक है, तुम हाँ ऐसे करके, ठीक है। अब अभी मैं इसको डिटेल में भी समझाऊंगा स्टेप बाय स्टेप लिख के, बट दैट विल टेक टाइम। ओके, सो व्हाट आई टोल्ड यू स्टूडेंट्स, सो यू कैन चेक the full playlist of 2025 this exam solution, okay, if you want to detail solution in the ing mathematics channel, you can check it out there, okay। so ऐसे होगा, ठीक है। फिर ज्यादा जिसको समझ में नहीं आया बच्चों, वो इस ये नॉन एम्प्टी है, फिर सोचना आप लोग आगे, ओके, नॉन एम्प्टी ओपन सेट तो कैसा दिखेगा, फिर आप लोग समझ। Okay, so let me stop here, and I again ask you, if you have any questions, then please feel free to ask. Otherwise, we end the session here. And I really enjoy solving the problems with you. Okay, I hope you also do that. Okay, so let me stop the recording. Yeah. So anything do you want to say? Anyone?
Yes, sir. You have stopped the recording. Okay.
No, I mean, okay, so which one is, so you want stop? You
Yes,
want
I want a
recording to
question,
stop?
not. Yes.
Okay, okay, I will stop the recording.
Yeah,
Fine.
stop the please recording and.
Okay.
Yes, sir.